This is the lecture video for section 7.4, Geometrically Defined Vectors and Application. This is the first video. Here I'm going to first talking about some basic terminologies. Next, I will introduce the vectors. And then third, I'm going to talking about the geometric properties of parallelogram. In general speaking, for any quantities, we only have two types of quantity. The one is called the scalar quantity, which means the quantity is involved magnitude only and can be represented by real number, such like a speed, 50 miles per hour, that is a scalar quantity. The second type of quantity is called vector quantity. Vector quantity is talking about quantities involving both magnitude and direction. For example, we're still using the speed, 50 miles per hour as an example. In order to be a vector quantity, I need to talking about 50 miles per hour south. So I need to have the direction. So you can thinking about scalar is more like just a pure number. Vector or vector quantity is talking about I have a pure number, which is the scalar part, plus a direction. Which direction are we talking about? Going to the south, north, forward, backward, or upward, downward. Last part of this video, we're going to talking about the geometric properties of a parallelogram. Since we're talking about sum of two vectors and the difference of two vectors we use in parallelogram, so here we're just going to quickly talking about them. So first, parallelogram is probably a term you never, or you hardly hear about it, but parallelogram is more is a type of geometry shape, having a lot of different, it's a more bigger families, having a lot of different subcategories. For example, a nicer parallelogram is called a rectangular. And then one even more nicer parallelogram is called a square. So you can see parallelogram is more like a bigger family, and inside parallelogram we have different subgroups. So here we're going to talking about three properties about parallelogram. The first property says a parallelogram is a quadrilateral, meaning is a shape with four sides whose opposite sides are parallel. So opposite sides are parallel. So the top and the bottom are parallel to each other. The left and the right are parallel to each other. Because they are parallel, we have the following second option or second properties that says that the opposite side and the opposite angles of a parallelogram are equal. So those two sides have the same length, similar to the other two sides. Also, their opposite angles, this angle and this one has the same measurement. And those two on the corner has the same measurement. Since they have the same measurement, then second part of the second property says the adjacent angles of a parallelogram are supplementary. So these two angles are called adjacent angles. So if I adding those two angles together, I will add up to 180. So supplementary angles. Similar to those two, and those two. Then the third property is talking about the diagonals of a parallelogram bisect each other. So I need to talking about the diagonals. So bisect each other, that means when they intersect, the intersection point is their midpoint between for each of those two diagonal lines. However, depending on the shapes we have, for example, if we have a square, then the diagonal line also bisect the angles. Bisect means cut the angles into exactly the same half. If we have a rectangular, we probably don't have it. In general speaking, when we have a parallelogram, we might not have the property that the diagonal is going to bisect the angles.